Welcome to part 2 of irrational numbers for class 9. In this lesson, we will rationalize denominators, prove two useful results, and solve simplification problems step by step. Every answer will be checked. To rationalize a denominator means to remove every radical from the denominator without changing the value. For a single square root, multiply by that same root over itself. For a binomial, multiply by its conjugate. The conjugate of a plus b square root c is a minus b square root c. Their product is a squared minus b squared c. Example 1. Rationalize 1 over square root of 5. Multiply the numerator and denominator by square root of 5. The numerator becomes square root of 5 and the denominator becomes 5. Therefore, the answer is square root of 5 over 5. A quick check shows that multiplying this answer by square root of 5 gives 1. Example 2. Rationalize 3 over 2 plus square root of 3. Use the conjugate 2 minus square root of 3. The denominator becomes 4 minus 3, which is 1. The numerator becomes 3 times 2 minus square root of 3. So the simplified answer is 6 minus 3 square root of 3. Example 3. Rationalize 5 over square root of 7 minus square root of 2. Multiply by the conjugate square root of 7 plus square root of 2. The denominator is 7 minus 2 or 5. Cancel the factor 5. The answer is square root of 7 plus square root of 2. Now prove that 1 over square root of 5 minus 2 equals square root of 5 plus 2. Multiply by the conjugate. The denominator is 5 minus 4, which equals 1. Therefore, the numerator square root of 5 plus 2 is the complete answer. So the identity is proved. Prove that square root of 3 plus square root of 2 is irrational. Assume for contradiction that it equals a rational number r. Squaring gives 5 plus 2 square root of 6 equals r squared. Rearranging would make square root of 6 equal to r squared minus 5 divided by 2. That expression is rational, but square root of 6 is irrational because 6 is not a perfect square. This contradiction proves the original sum is irrational. Simplification 1. Open the square of square root of 5 plus square root of 3. Then subtract 2 square root of 15. The square expands to 5 plus 3 plus 2 square root of 15. The radical terms cancel, leaving 8. Simplification 2. Simplify square root of 9 plus 4 square root of 5. Look for two positive terms whose square has this form. Square root of 5 plus 2 all squared equals 5 plus 4 plus 4 square root of 5. That is 9 plus 4 square root of 5. Since both sides are positive, the original square root equals square root of 5 plus 2. Challenge problem. Simplify 2 plus square root of 3 over 2 minus square root of 3 plus its reverse fraction. Combine the fractions. Their common denominator is 4 minus 3 or 1. The numerator is the sum of the two conjugate squares. The radical terms cancel, giving 14. Avoid 3 common mistakes. Multiply both the numerator and denominator. Use the complete conjugate and simplify the denominator before cancelling anything. Also remember that a square root represents a non-negative principal root. To finish, use the same radical for a one-term denominator. Use a conjugate for a two-term denominator. Apply the difference of squares and verify by multiplying back or substituting. Careful algebra turns complicated radicals into clean exact answers.